In this video, we look at the types of three-phase connection. In the last video, we saw the generation of three-phase current using three separate coils. If we take out each coil and connect them across a load, it will be easy to understand. So, we have the red coil R connected to some load. Similarly, we have yellow coil Y and blue coil B connected to some loads as well. We have purposefully isolated each coil to make you understand the connections in a better way. The current is assumed to be positive when it flows from finishing point to the starting point in each phase. Now, these three-phase voltage system can be used in two ways. In the first case, the three phases can be used independently to supply power to different loads. Each load gets power from a single phase of three phase. This is the type we use in domestic power supply like lights, ovens, etc. In the second case, the loads are connected to form a three-phase system. All the three phases are used together. The loads can either be star connected or delta connected in the three-phase system. This type of load is called as a three-phase load. The best example of a three-phase load is the three-phase induction motors. In this isolated three-phase system, we use 6 individual conductors to connect it to the loads. This arrangement is expensive and also complex. It can be simplified by connecting the wires in different way. Depending on the interconnection of the wires, there are two kinds of three-phase systems: star connection and delta connection. Let us look at star connection. We'll name the conductor wires of each coil now. In the red coil, we have two conductors, 1 and 2. Similarly, we have conductors 3 and 4 in yellow coil and 5 and 6 in blue coil. In star connection, one of the ends of all three coils will be connected together at a common point. The similar ends can either be starting end or finishing end of the coil. Let us just say we take out the finishing ends of each coil and connect them to a single point N. The other end is free and loads will be connected to these ends. Let us make this circuit into a more understandable circuit. The connections are similar, but it is convenient to see it this way. Now, the instantaneous values of the three-phase currents are IR, IY and IB. The subscripts denotes the coil colors. The current flowing in the common conductor Mn will be the sum of these phase current, that is IR plus IY plus IB. It will flow in the positive direction from M to N. The junction N is referred to as the star or neutral point. The three-phase motors are connected to the end-of-line conductors R, Y and B. However, single-phase gadgets such as lamps, heaters, microwave ovens are connected between one line of conductor and the neutral conductor Mn, as we see with the loads L1, L2 and L3. If the three loads are exactly equal, the phase currents flowing through them have the same peak value Im and differ in phase by 120 degree. So, the current in the neutral wire Mn will be 0. This is because IR is equal to Im sin omega t, Iy is equal to Im sin omega t minus 120 and Ib is equal to Im sin omega t minus 240, or we can write it as Im sin omega t plus 120. If we add all these currents, the sum will be 0. So, the current in Mn will be 0 amperes. If this is the case, we can remove the neutral wire Mn. We connect the coils in different way, which also looks like a star or Y. This is the case with balanced loads where all the loads are equal. In an unbalanced star connected load, the current flowing in each line would be different as the loads will be different. But according to KCET, the sum of the three line currents must still be 0. Now, before we end this video, let us look at a couple of important definitions. First one is the phase voltage. Let us consider the star connection again with a neutral conductor Mn. If we measure the RMS voltage drop across any one of the terminals of phase or coil and the neutral conductor, it will give us the phase voltage. So, the voltage Vrin between the red coil and the neutral conductor is the phase voltage. Similarly, Vyn and Vbn are also phase voltages. The next term is the line voltage. The term line voltage is used to denote the voltage between the two lines. So, Vry represents line voltage between the lines R and Y. The other line voltages are Vyb and Vbr. The relationship between the phase voltage and the line voltage can be derived easily with the help of a phasor diagram and the concepts of line and phase voltages which we learned in this video. In star connection, we get line voltage VL to be equal to √3 times the phase voltage VPH. But the relationship between the line and phase currents are a bit different. In star connection, the line current is equal to phase current, that is IL is equal to IPH. The same current flows through the phase winding as well as in the line conductor as it is connected in series with the phase winding. This is all about star connection in three-phase system. To sum up, we learned star connection of loads in three-phase. After that, we learned about the line voltage and phase voltage, which is VL is equal to √3 times VPH. And finally, the relationship between the line and phase current, which are equal. In the next video, we learn about delta connection of loads in three-phase system. See you there.